Hi, I'm Sean. I just completed the Salesforce Agentforce champion global badge. They're coming out with two more, which is exciting. The two more that they're coming out with most likely will be more hands-on. So I created a series to kind of bridge the gap. This is going to be introduction. So just a few minutes of introduction to machine learning and also what a notebook would look like. So Salesforce does a great job with their Agentforce and explain how to make agents such as like prompt builder, how to use the tools and make agents on the platform and configure it on the platform. However, it kind of skips on machine learning and generate AI in general, so how to make them. You can actually deploy your own models. Salesforce doesn't talk about this with Trailhead really because it's you don't have the capabilities of doing this. But technically, you can bring your own models if you know how. So this means that you are coding it in a notebook and then deploying it. So using like LangChain or Gang or GT. But you have to know how to code them to start with. Anyways, without further ado, this is a data set on Spotify. So here we have different columns. We call these features. The machine learning has four different main categories. You have supervised, unsupervised, reinforcement learning, and deep learning. Deep learning and reinforcement learning are their own categories. Um, Reinforcement learning, you can think of it like those vacuum bots. So they can vacuum up stuff and they know like not to hit something repeatedly. Is using reinforcement learning. Without all the math is simply +5 for not hitting something and then -5 for hitting something. And then it's best practice to just give like a -1 or something like that, something small, just to make a move. Kind of like chess, for example, you want the um model to think about its moves ahead of time. So kind of think about it before just moving quickly into a decision. And then supervised learning is when there's a target. For example, this view here, maybe we're working for a studio, a music studio, and they want to know um most views, predict the views, for example. And that would be a supervised business use case. And specifically it'd be a numerical because these are numerical. Here's a classification supervised use case if we want to know predict like is it going to be Spotify or YouTube? It could be like true or false, for example, too, because there's only two values. Um, but that would be classification. If there was another column and it was like repeat listeners or something like that, did they listen to the song again? Kind of thing would be a classification supervised problem. It is supervised because we know what we're predicting. Unsupervised, we don't know what we're predicting. And a classic example would be like clustering. For example, maybe this was a shopping data set, and then you had customers. We want to cluster our customers, so segment them. So maybe there's like high spinning and quantity of products, like how many products they get weekly or monthly, or how often they come to the store. Um, Income level, and then we can cluster them on that. So are they high income, high spending, frequently coming, kind of thing, or are they low income, high spending, frequently coming, high income, low frequently coming, and then spending less. So that this would be a prime example of a target audience that you would want to try to get promotions too, because we know that they have the income, they have that they're high income, but yet they're not spending that much. So it's just a way to cluster them, and then we can um, target those clusters independently of from each other. That way we can get into relevant promotions. And then also too, recommendation system would be another example of unsupervised. So if you watch Netflix, for example, that would so if you watch Netflix and you watch a show and it recommends another show, that's unsupervised because we didn't know what the user would watch. If you buy something and it recommends something else related to that, or click on something and it recommends something else relevant, that's unsupervised as well. Again, because we didn't know what the end user was going to click on. Um, so hopefully that clarifies what machine learning is, the different categories of machine learning, and then also to just more grainier the models. Certain models are for certain use cases. So if you have a business problem and it's classification versus like a numerical problem, when I find like the price or number of views or something like that, we have to find the model that's relevant to that. And then you can also train 3 or 4 different models and then recommend to the stakeholders or your supervisor which model that you recommend out of the 3 or 4. So it's good to test out more than one model. Um, that way you can see which one performs the best and recommend going forward with that one. So these are features. This would be considered the target features. So features are a column or the columns. We just call them features. And then the target is always going to be your Y feature, and the rest of the data set is going to be your X. So whatever else is left in there. Um, and here's a notebook. This is what you're going to commonly see when you make a machine learning model or when you make generated AI applications from scratch. So you have a notebook. This is using Google Colab, but you can use also Jupyter notebook. That's pretty common as well. You can use VS Code as well. These are libraries. And then the reason why Python is very popular is because of the different libraries. If I wanted to input um like stock, for example, I can use Yahoo Finance. So essentially a way to web scrape without needing like APIs and all that. You can just use the library, and then within less than a minute, I can pull in like Tesla or Google stock just using their tick. They call them ticks. They're just abbreviation for um the stock, the company of the stock. But these are all libraries. So this is libraries for handling arrays and then the data frame. So manipulating the data set. These are charts. Uh, Here's your machine learning libraries. So building the model. And then you can use um like Streamlit, for example, for a UI. So maybe you have a car and you want the user to input year, model, make, and then the output would be the prediction. So that would be a machine learning. Um, you can also deploy uh these notebooks to AWS and Azure, for example, and then it would make a pipeline for you, so the flow of it, and then it'd be on the cloud. Um, the difference between machine learning and generative AI is machine learning is primary for predicting, and generative AI is more for um essentially getting or prompting, but they can be combined. Um, so you can have generative AI that uses NLP, for example, natural process language, or you can have like ChatGPT, you can upload a photo and analyze it. So that would use some kind of a visual processing, something like CNN or something like that, um, to be able to read the pixels of the image. So there is some kind of machine learning that's combined with the generative AI. But when you separate them and you're just doing machine learning and generative AI, the main difference is machine learning is for predicting, and generative AI is for prompting and getting some kind of output based on that prompt. Um, is the primary difference of it. And going forward, there's be more on like data cloud, Agentforce projects, and then machine learning projects as well as Gen AI from scratch.